Okay, so we're going to evaluate the integral of x squared ex dx. And before I go any further, try it yourself. Pause the video, try it yourself, and see what you come up with. Now that you're back, when I look at this, I see that it's multiplying. I also know that the derivative of ex is ex, and this x squared is not inside here, so there's no substitution to do. And so I'm left with integration by parts as my go-to method. And I typically choose my u to be the polynomial or ln x. But here's my polynomial x squared. So I'm going to let u equal x squared, which means dv is equal to e dx dx. Differentiating this side, du over dx equals 2x, multiply the dx over, and I get this. And on this side, I integrate both sides, and I end up with v. The integral of e dx is just e dx, which is a quite simple integral to do. Now, plugging it back into my formula, it ends up being u is x squared times v is e dx, x squared times e dx, minus my v, which is e dx, times du, which is 2x dx, 2x dx. Now I have to integrate this, but when I look at this particular problem, it's not very simple for me yet. I can't use substitution. I have to do something. I'm going to pull the 2 out. And so what I have to do is I have to do integration by parts a second time on this. And so I'm going to make u is equal to x, dv is equal to e dx dx. So when I differentiate du, I get dx, and when I integrate, I get v is equal to integral of ex is just e dx. And so this is from before, minus 2. Using this formula, I refer back to my integration by parts. I need to put this part in as this integral. So I have u times v minus v e dx times du dx. And then I keep on simplifying x squared x minus 2x e to the x plus 2 plus multiplying here plus 2. Now the integral of e to the x is simply e to the x plus c. And that is using integration by parts 2 times. And this is a common phenomenon when you have e to the x and a polynomial of a higher degree than 1, is you often have to break it down. So it went from an x squared to an x to no x. If this would have been an x to the power of 5, you would have to have done integration by parts probably like 5 times to break it down slowly to x to the 5th, x to the 4th, and so on. But this is another example of how we use integration by parts.